the topic we are discussing today. The hidden risks behind the low efficiency of human-machine collaboration. Most manufacturing companies believe that adding more automation will naturally improve human-machine collaboration. In fact, many projects have experienced the opposite. Machines are installed with systems and become smarter. Automation has increased, but overall production efficiency has hardly improved. Operators become busier. Machines spend more time waiting, and the production process has become more fragmented. Why does this happen? From the perspective of industrial risk management, the problem is not usually the technology. The real risk lies in the boundaries of responsibilities have never been designed. Many automation projects focus on how to divide the work. Some tasks are given to machines, while other tasks are still done by humans. But successful human-machine collaboration is not about dividing workloads, but about defining responsibilities. Who makes decisions? Who performs tasks? Who confirms completion? Who handles exceptions when problems arise? Who takes over? If these questions are not answered during the system design, have never been answered, then human-machine collaboration will become a series of mutual interruptions. Imagine a typical production line. The machine completes the cycle, but it must wait for the operator to confirm the next step. The vision system completes a detection, but the operator checks it again. An abnormal situation occurs in the same product, and both the operator and the system think the other will handle it. Everyone is working, but neither side has the full responsibility for the entire process. This forms the most common risk in industrial automation: the unclear interface of operational responsibilities. The consequences are not only inefficiency, but also unnecessary waiting, duplicate operations, decision-making delays, and greater operational uncertainty. Lean production defines waiting as one of the 7 wastes. ISO 12100 in the process of mechanical risk assessment and system design. Operation responsibilities should be considered. These principles all point to the same conclusion. Only relying on effective human-machine collaboration cannot be achieved. Only clear responsibilities can achieve it. So, how manufacturing enterprises should reduce this risk? First, clearly distinguish between decision-making and execution. Machines should perform standardized and repetitive tasks, while personnel should focus on judging abnormalities, processing, and decision-making. Second, define each interaction interface, and clearly define when the machine starts and when the operator should intervene, when the system automatically continues, and who is responsible for each anomaly. Any process should not be based on guesswork. Third, continuously optimize the workflow. Rather than adding unnecessary confirmation steps, more checkpoints may not necessarily reduce risks. In many cases, too many control measures will only create new bottlenecks. Efficient human-machine collaboration is not achieved by making both humans work harder to achieve, but by letting both sides within clearly defined boundaries to complete their respective best tasks. With the development of artificial intelligence and intelligent manufacturing, this principle will become more important. The biggest risks are rarely technological deficiencies, but on the basis of imperfect duty design. To build advanced automated systems, when responsibilities are clear, will become stable. When collaboration becomes productivity stable, will increase accordingly. And this is the beginning of realizing the value of automation.